Similarity transformation. We will begin by drawing non-rigid transformations. Triangle GHI has vertices at point G, -4, 2, point H, -3, -3, and point I, -1, 1. Suppose the triangle is translated 4 units to the right and 2 units up, and then dilated by a scale factor of 2 with the center of dilation at the origin. Sketch the resulting image of the composition of transformations. A series of slides will follow. Before looking ahead, try to design a strategy that will lead to a sketch of the composition described, and then check to see if your strategy is the same as the strategy that follows. The first step is to draw a triangle GHI. So point G is at -4, 2, point H is at -3, -3, and point I is at -1, 1. We can connect the points that we just graphed to form triangle GHI. Now let's translate it to the right 4 units, or in positive direction 4 units, and up 2 units in the positive y direction 2 units. So we can go with point G, 1, 2, 3, 4 to the right and up 2. This will be point G prime, which has coordinates of 0, 4. Point H will be moved 4 units to the right and up 2. So H prime will be right here at 1, -1, and point I will move 1, 2, 3, 4 units to the right and up 2. So we will be at coordinates 3, 3. Now that we have our coordinates graphed, we can connect them to draw triangle G prime, H prime, I prime. The next step is to locate the points of triangle G double prime, H double prime, I double prime, which will be the image occurring after a dilation with a factor of 2 about the origin of triangle G prime, H prime, I prime. So in order to find those points, we'll first draw straight lines out through each of these coordinates so that we can see the path of the dilation when it occurs. So they're each going to follow every single one of these lines, and we're going to go out to be double. So the distance from the origin to point G prime is 4, so therefore the distance between the origin and the point G double prime will be 8. So G double prime will be up at this point, 0, 8. To get from the origin to I prime, we have to go diagonally 3 units up and to the right. So let's do that 6 times to get I double prime. 1, 2, 3, 4, 5, 6. And now to get from the origin to H prime, it's 1 unit diagonally down and to the right. So in order to get H double prime, we're going to go down 2 units diagonally to the right. So H double prime will be right there at these coordinates. And the coordinates for H double prime will be 2, -2. And the points for I double prime, or the coordinates for the point I double prime, will be 6, 6. Another way you could have found these points would also be to take the coordinates of points G prime, H prime, and I prime and multiply them all by 2. That's another way that you can get the coordinates for the image points after a dilation centered about the origin with a scale factor of 2. And the last step, once we found the coordinates of our points G double prime, H double prime, and I double prime, we can connect them to draw our triangle. G double prime, H double prime, I double prime. And here this slide shows again what triangle G double prime, H double prime, and I double prime will look like. Let's try another example where we are drawing similarity transformations. Triangle LMN has vertices with point L being at 0, 2, point M being at 2, 2, and point N being at 0, 1. Sketch the resulting image of the composition of transformations. We're going to dilate the triangle after reflecting it across the x-axis. So let's first start by drawing our triangle LMN. So L is up here at this point, M is to the right 2 and up 2, and N is at 0, 1. Okay, so here's our triangle LMN, or our pre-image that we're starting with. Okay, and again, this reads as dilation with a scale factor of 2 after a reflection across the x-axis. So we have to reflect it across the x-axis first. So we're going to go down 1 for point N, so we have to go down 1 again for point N prime. For L, we have to go down 2 to get to the x-axis, so we have to go down 2 again. And then for M, we have to go down 1, 2, and then another 2. So here is triangle L prime, M prime, N prime. And after we reflected it across the x-axis, we're now going to dilate it with a scale factor of 2 about the origin. So let's draw our points from our center of dilation, the origin, and extend lines out, going through the key vertices. Okay, so these are going to be the pathways that we are going to follow to get the coordinates of our new triangle when we dilate it. So if we start with N prime, we only had to go down 1 to get to it. So we're going to have to go down 2 to get to N double prime. To get from the origin to L prime, it's down 2 units, so we have to go down a total of 4 to get to L double prime. So that point will be right here. And then to get from the origin to M prime, we have to go down diagonally and to the right 2 units, so we're going to double that and go down into the right 4 units. 1, 2, 3, 4. So this is where M double prime will be. And now we can connect these final image vertices together to create our final image. And here's the final solution for the dilation with a scale factor of 2 after a reflection across the x-axis of triangle LMN. It produced triangle L double prime, 0, -4, M double prime, 4, -4, and N double prime, 0, -2.